Hello, this is my demo for 7A off the quiz. So this is going to be a video on a 10 digits device, which is a keypad that's going to output a high value. So it's going to be an on, a 1, which is an SOP expression. If it wasn't SOP, it was POS, we'd count the zeros. But we're doing an SOP device. We're using SOP to calculate. So it says that the high value, if will output if only the number is larger than decimal 6. So if you see here, I've got a truth table with all the possible outcomes that could result from 4 bits. You got A, B, C, D, and you can see here all the columns have the calculations in them. And so when we do the calculations, 0 to 6, because it has to be greater than 6, it's going to get a 0. We don't want a high output for that to fulfill our device. We only want for 7, 8, and 9. 10 will make it an 11 digit, and we only want 10 because don't forget you have the 0. So 0 to here makes it 10. 0 to 9. We do count to 0. So these ones do transfer onto the 4x4 K-map, but also you do have to count the don't cares. Don't care is a neutral, meaning we could use them, we don't have to use them, but in order to simplify our circuit, we want to factor in all the don't cares, so that way we get an accurate result. So you see, we have 1, 2, 3, 4, 5, 6. We don't care because we don't care if it's on or off. So we can use it to our simplification. We can simplify it with this. So doing so, we transfer the information here. So we've got our ones. I've got 1, 2, and 3 ones here. Those are our high outputs that we do care about. That's the ones that we want to output when it is greater than decimal 6. We want that to turn on. So we have to factor that in and come up with the expression. Now the X's is the don't care expressions. We don't care about those inputs. They could be on or off. For our circuit, it doesn't matter. For other circuits, it could matter. But for this scenario, we only care about the ones. So when you simplify this, when you add up the columns that are all the same, this is your final expression that you get simplified from the K-map. You get A plus B, C, D. And then from here, you can make your circuit to build this device. So this is all of what's required to unsigned binary for a 10-digit keypad.